Understand a very practical problem from physics and finite element analysis. Here, a force F is applied on a surface at some angle. And you want only the tangential component, sliding force, on this surface. This surface has unit normal, denoted by n. First, we compute F cross n. This removes the component of F along the normal direction and gives a vector perpendicular to both F and n. Next, we take n cross F cross n. This second cross product rotates the vector back into the plane of contact. The final result, n times F times n, is the tangential force vector acting on the surface. This is a classic triple cross product. Now main question is, why do we use this method? Because it gives a direct vector projection onto a plane, it is numerically stable, and it avoids computing angle or trigonometric functions. That's why triple cross products are widely used in FEA contact mechanics, friction models, and physics engines. In the previous lecture, we studied the triple dot product, where the result is a scalar value, and it represents the volume of a 3D parallelepiped. Now, in lecture 6, we move one step further and introduce the triple cross product. The triple cross product is written as A cross B cross C. Unlike the triple dot product, the result here is not a scalar, it is a vector. This operation appears frequently in computational geometry, physics, and simulation algorithms, especially when we need to project vectors, remove unwanted components, or find directions constrained to a plane. Now let's understand the triple cross product, also called the vector triple product. We start with three vectors A, B, and C. First, we take the cross product of B and C. The result, B cross C, is a vector perpendicular to the plane formed by B and C, shown here as the vertical vector. Next, we take the cross product of A with B times C. So mathematically, the triple cross product is written as A cross B cross C. Notice something important here. Even though B times C is perpendicular to the plane of B and C, the final result A times B times C lies inside the plane formed by B and C. This means the triple cross product pulls the vector back into the B-C plane. Key conclusions are: the result of a triple cross product is always a vector, not a scalar. The result is coplanar with vectors B and C, and it is perpendicular to vector A. Here is comparison for triple dot and cross products. In short, triple dot product gives a number, it tells you volume and validity. Triple cross product gives a vector, it helps project and fix geometry. Triple dot measures and triple cross corrects. That's the real difference. These are the key properties of triple cross products. I request you to pause this video and look into this and try to understand these important shortcuts. If you want geometry explained the way CAD, FEA, and simulation engines actually use it, subscribe to MathAlgo Studio and join the community.